So, in the last lecture we have seen an important property, an interesting property of reciprocal lattice, that the reciprocal lattice vector HKL or G star HKL, as I have denoted it here, is perpendicular to the plane, the real lattice plane HKL. Now, today we will derive another interesting relationship, that is the length of the reciprocal lattice vector is reciprocal of the interplanar spacing of the HKL plane. So, DHKL is the symbol for interplanar spacing, and that also requires a definition, a careful definition. It is not so obvious what is DHKL, and sometimes it is left little undefined, but we should define it precisely. So, the way we will define DHKL is to construct planes. Given any HKL, we will construct planes with intercept n times A by H, n times B by K, and n times C by L. HKL are number, A, B and C are length, n is again an integer. So, all these are 3 lengths. What you are having is 3 lengths, which will vary as you will vary n. So, for n is equal to 1, you will have A by H, B by K and C by L as intercepts, and considering these as 3 intercepts, you get a plane. The next plane for n is equal to 2 comes at 2 A by H, 2 B by K, 2 C by L. Similarly, 3 A by H, 3 B by K, 3 C by L. So, you let n vary over all integers. So, n varies over integers, that is n can be anything from minus infinity, minus 2, minus 1, 0, 1, 2 and so on. These are now periodically spaced planes, because first plane is making intercept A by H on the x axis, the next plane is making an intercept 2 A by H, the next plane is making an intercept 3 A by H. So, on the x axis you can see they are going in a periodic way, and same with y and z axis. So, in the space also they are periodically spaced with a fixed spacing. That fixed spacing is what we are defining as the DHKL of this set of planes. So, spacing between any two successive planes is the DHKL. So, let us say for n is equal to 1, we have the spacing A by H, B by K, C by L, intercepts, not a spacing, intercepts. So, if I have my axes, all I have to do is to make a plane with x axis intercept as A by H, y axis intercept as B by K, and z axis intercept as C by L. So, I get a plane. Notice that this is only a piece of plane. When we say plane, actually you have to extend this in your imagination. This is only part of the plane intercepted by the 3 axes. So, the plane is actually extended into infinity, of which this triangle is only a part. Now, if I take n is equal to 0, you will get all 3 intercepts as 0. So, that means that plane will be passing through origin, and we will draw that plane passing through origin, but parallel to this original plane. So, which means now these two planes are spaced by some distance, and that distance is what we will call the d spacing. So, we can also say that d spacing is distance from origin of the plane with intercepts a by h, b by k and c by l. This will become, because the distance between this plane and this plane, since the red plane is passing through origin, you can drop a perpendicular from the origin onto this plane, that will also be same DHKL. So, now let us try to establish that relationship, the relation between G star HKL, the reciprocal lattice vector HKL, and the plane HKL. So, let us drop a perpendicular OP. We are dropping OP, a perpendicular on the plane ABC. Plane ABC is my HKL plane, which means OA is its HKL plane. So, from what we have said, OA, the first intercept is A by H, OB, the second intercept is B by K, and OC, the third intercept is C by L. That is the meaning, that is the definition of Miller indices, that is the meaning of an HKL plane. So, we get these three intercepts and we drop a perpendicular. By very definition of what we said about DHKL, the length OP is DHKL. And from what we have proved the earlier relation between G star HKL and the plane, we know that G star HKL is normal to the plane. So, which means G star HKL is also in the direction OP. So, G star HKL is in the same direction. From the previously established relation, that G star HKL is perpendicular to HKL, OP is perpendicular to HKL. So, G star HKL is parallel to OP. Okay. Now, let us join P with A. Let us join P with A. This green line PA, and consider the triangle OPA.
What is G star HKL?
Sorry,
What is G star HKL?
G star HKL is the reciprocal lattice vector which means HKL are components with respect to the reciprocal basis. So, that means it is a vector with H as its first component with respect to A star. So, it is H A star. Similarly, K is the second component with respect to B star, and L is the third component with respect to C star. So, we are showing only A, B, C, we are not showing you A star, B star, C star, that will make my drawing too complicated, but we are assuming that A star, B star, C star has been calculated and they are also existing somewhere in this space, and now I am going H times A star, K times B star and L times C star. If I do that, then from the relationship the first relationship which we established last time, that G star HKL is supposed to be perpendicular to the plane, and that is why I am confident to draw my G star HKL vector also along OP, because I said OP is perpendicular to the plane, G star HKL is perpendicular to the plane. So, G star HKL is parallel to OP. Then G star HKL is in the same direction as OP. So, now since OP is perpendicular to PA, so we have this as our right angle, this is our right angle. So, you can say that OP is projection of OA on OP, okay, in this direction, in the normal direction. So, OA is being projected, because if you draw this triangle, let us say we draw it like this, we are going OP, this is OA and this is AP, and the angle APO is 90 degree, because in this orientation sometimes it is little disturbing to see, we usually like to draw it this way. So, you can see that OP is projection of OA in the triangle, in the right triangle AOP. In right triangle, each of the either the base or perpendicular, both of them are projection of the hypotenuse, because you go by perpendicular lines. So, OP is projection of OA on OP. Now, projection, how can you write in terms of the vector? Yeah, dot product of OA with unit vector along that direction. So, unit vector along G star HKL. So, OA dot n, where n is the unit vector along OP. So, which means this is O. Now, OA is what vector? OA length is A by H. So, vector is vector A by H. So, OA is A by H, and n we can write in terms of, because we know one vector along that direction, that is G star HKL. So, we can write this as G star HKL divided by the magnitude of G star HKL, that is the unit vector n. You are happy with this? Now, G star HKL as I defined is nothing but HA star plus KB star plus LC star So, now this is a dot product here. So, we can take A dot inside. So, we have H A dot A star plus K A dot B star plus L A dot C star. Now, what is A dot B star? That is 0. A dot C star 0 and A dot A star 1. So, you get the very interesting result. H into 1, the numerator and the denominator H cancel. So, you get DHKL as 1 by G star HKL, or if you want to write it in terms of G star HKL. So, length of this is what we wanted to prove, length of G star HKL is nothing but just by 1 by DHKL. So, this actually gives you a formulation also of finding DHKL. If you have to determine DHKL of any plane in any crystal, you should look for the corresponding reciprocal lattice vector and find its length. That is the easiest way, easiest mathematical way. Otherwise, if you try to actually draw the plane and do the geometry, you can do without reciprocal lattice, because the plane is in real space and we have already drawn the plane and we have dropped the perpendicular from the origin. You can always do sufficient geometry to find the distance of that plane from the origin to get your DHKL in real space itself, but that is going to be a little bit more challenging if you actually try to do that than finding algebraically the length of reciprocal lattice vector. So, the unit of reciprocal lattice vector, as you have seen the very definition, that A star was B cross C by the volume of the unit cell. So, if you think in terms of angstrom as the unit of B and C, so you have angstrom into angstrom by the volume is in angstrom cube. So, you have 1 by angstrom. So, you can see that the reciprocal lattice vectors will have length which is 1 by angstrom or 1 by meter. That is one of the justification of using the word reciprocal, and we will keep seeing that there are many other justification for the word reciprocal. Just now we saw now that DHKL of real space is reciprocal of G star HKL.